Hello, we're going to talk some about Triangle Inequality Theorem today. We'll start off with a little joke. Why is the obtuse triangle always mad? Well, because he's never right. Poor thing. All right, so here's some important facts to go over regarding triangles. A triangle has 6 parts to it. It has 3 sides, and it has 3 angles. The sum of the angles in a triangle is always going to equal 180 degrees. A triangle is named by its vertices. So like if we're going to name the triangle and its parts here, the vertices would be A, B, C. So you could name this triangle ABC. You could really name the triangle BCA. You could name it CAB, as long as you're going in the same order there. So, this is giving you line AB, there. And then you would continue going. You have line BC, and then you have line AC. Those are all lines of your triangle. You can also name your angles here. So this is a symbol for angle. So this is saying angle ACB. I'm not sure how to move that. There we go. You can also, again, as long as you're keeping your letters in order, name it a different way. Angle BAC. Then you have angle CAB. Here's another one. Keep moving my little thingy here. So if you want to practice naming that, you can pause the video. So that would be triangle RST. You can again name your line segments there. Line RS, line ST, and line RT. You could always reverse those orders as well, and that would be fine. We can name by angles here. Angle RST, angle TRS, and angle STR. So when we are classifying triangles or naming triangles, there's 2 ways to name triangles. One is to name or classify triangles by the side lengths. We have equilateral triangles where all sides are equal. You have isosceles triangles where 2 sides are equal. I like to remember that by saying isosceles. I have 2 eyes, therefore that just helps me remember that isosceles triangles have 2 sides that are equal. And then we have scaling, where they have no sides that are equal. Classifying triangles by angle measures. We have a right triangle, which has at least, or not at least, it has one 90-degree angle. We have acute triangles, where all angles are less than 90 degrees. And we have obtuse triangles, where it has one angle greater than 90 degrees. If you have one right angle in a triangle, that automatically makes it a right triangle. If you have one obtuse angle in a triangle, that makes it automatically an obtuse triangle. And then we have equiangular triangles, and that is a triangle that has all angles that are equal. So the triangle inequality theorem is actually not too crazy. It says that the sum of any 2 lengths of any 2 sides of a triangle is greater than the length of the third side. So it could say that the sum of the 2 shorter sides must be greater than the longest side. It's just a different way to word that, maybe a little simpler terms. If the third side is equal to or more than the sum of the 2 other sides, then is not form a triangle. It is important there to note that it's saying that if it is equal as well, that would make it not a triangle. So here are some examples for you. So if we have 5, 8, and 16, this one's already in order from us from the smallest side to the largest side. So we would take these 2 smaller sides and add those together. 8 plus 15, and you're going to ask yourself, 8 plus 5. Is the sum of 8 plus 5 greater than 16? In this case, the answer is that 5 plus 8 is not greater than 16. It is indeed smaller, so this cannot be a triangle. Here's another example. 6 and 11, we would add those 2 together and see if 6 plus 11 is greater than 14. So we know that 6 plus 11 is 17, so that is greater than 14. So that one can be a triangle? Your answer would simply be yes there. Here's another one. This one does not put it in order for us. So the first thing I would suggest doing there are putting these in order from your smallest to your largest. So 8 plus 5, and we want to see if 8 plus 5 is larger than 13. Again, notice I'm saying larger because in this case, 5 plus 8 is going to be actually equal to 13. But because it is equal, the rule says that it must be greater than. And since it is equal, this would not be a triangle. If two sides of a triangle are given, sometimes they might ask you to decide or describe the possible lengths of the third side. So here it's saying if we have a side that's 2 yards and we have a second side that's 6 yards, what possible values could work? And so you're going to compare the sum of two shorter sides to the longest side. So here, if the third side was 1, that would be that 1 plus 2 would be 3, and that would not be larger than 6, so that would not work. If the third side was 2, 2 plus 2 is 4, and that is still not larger than 6, so that also would not work. If the third side was 3, 3 plus 2 is 5, we're still not larger than 6. What about 4? We're now at 4 plus 2. Is 4 plus 2 greater than 6? It's still not greater than, so it's still not a triangle. I think we're getting close though. We have 5 plus 2, which is 7. 7 is now greater than 6. So we can say, yes, that would be a triangle. And we can keep going from here. We can look at if the third side was 6, if it was 7, those would both work. If those were 8, that would both work. That would not work because now, sorry, I was getting a little fast there. 6 plus 2 is 8. Is 8 larger than 8? It is not. So that one is not going to work out. So now we can sit and we can look at this chart here and we can determine what numbers would work and we can write that out. You can also keep going from there. 6 plus 2 would be 8. Is 8 larger than 9? No. If the third side is 10, 6 plus 10 is 8. 8 is not, so that would not work as well. So the third side has to be bigger than 4, which we found in the chart here, but it has to be less than 8. So they've written this out as an inequality, showing us x is representing that third side and putting that there. All right, thanks so much for watching.